Question 1. Find the interquartile range of this set of numbers. Interquartile range is found by taking the upper quartile and subtracting the lower quartile. Another way of saying it is interquartile range is Q3 minus Q1. So what we do is we cut the set of numbers in half. In this case it goes right through the middle of one of the numbers, so it must have been an odd number of scores there. Yeah, it looks like there's 11 scores there. So that middle score is 106, that chops it all in half, and then we consider the top half and the bottom half as separate ideas. So we'll find the median, or the middle number in the top half, will be 109. That'll be what we call Q3, or our upper quartile value. And we'll do the middle, find the middle of the lower half, which is 104. We'll call that our Q1, or our lower quartile value. Notice we don't really consider, as part of the rest of the question, that 106 middle number once we've decided that that's the very middle of the two. It's like the median of the odd number of scores there is 106, and then we'll just think of it as two separate questions for the top half and the bottom half. So we'll take 109 minus 104, and that will give us what we call the interquartile range. In this case, an interquartile range of 5 for that set of scores. Question 2. State the maximum score from the box plot shown below. The maximum score for a box plot is just that final notch on the right hand side. The highest value there will be 37, the maximum score of 37 for that box plot. Question 3. State the minimum score from the box plot below. The minimum score can be found by having a look at that final notch on the left, and that has a value of 25 here. Minimum score for that box plot is 25. Question 4. State the median score from the box plot shown below. The median is that line that's in the middle of the rectangle there. In this case, the median score of that box plot is 31. Question 5. State the interquartile range from the box plot shown below. To find the interquartile range, we have the upper quartile minus the lower quartile, or Q3 minus Q1. So we'll find that on our box plot. Q3 is that right-hand edge of the rectangle. In this case it's got a value of 35 that we can read off, and so 35 is our Q3. Our Q1 can be found by having a look at the left-hand edge of the rectangle, so that has a value of 27 in this case. So if we take 35 minus 27, we get an interquartile range from the box plot of 8. Question 6. The top 50% of scores occur between which two values? There are 25% of the scores in that first section of the box plot to the left of the rectangle. There are 25% of the scores in that left-hand section of the rectangle, in the right-hand section, and in the last section as well. So a box plot breaks up scores into quarters, really. And so the top 50% of the scores will include the very right-hand 25% and the next 25% to the left of that. So the top 50% of scores we can see there occur between 31 and 37. It's the top half of the box plot really. So we'll read it off that way. Question 7. Find the mode from the stem and leaf plot shown below. The mode is the score that occurs most often. And in this case we can see the only score that occurs twice is 72. We say it's a mode of 72. Some students will say that the answer there is 2. But in a stem and leaf plot, the leaf part is just the units number there in this case, and so the numbers aren't 3, 5, 8, 9, 0, 2, 2. They're 53, 65, 68, 69, 70, 72, 72. So you can see that the actual scores indicated by those 2s are 72s, and that's the only one that occurred twice, so that's our mode. Question 8. Find the range from the stem and leaf plot below. Range is the highest score minus the lowest score, so let's have a look at that. Our highest score is 94, not just 4 but 94, that's the largest value there. And our lowest score is 53. So don't just take the leaf, it's got to be joined with the stem. The stem kind of forms the tens column there, and the leaf the units column in this case. So our range can be read off by 94 minus 53. We have a range of 41 in the shown in the stem and leaf plot. Question 9. Find the median from the stem and leaf plot below. The median for an odd number of values, and I think we've got 11 values here. Let me check. 15 values, okay. So we do have an odd number of values, and the median from odd number is the single middle value once the data is placed in order. The stem and leaf plot kind of places the numbers in order anyway. So let's have a look. I've circled the 9 there. The value is actually 79, but just to have that as our median, we have to make sure that there are the same number of scores below that number that we call the median as there are above that number. So I'm just going to check. There are 7 scores below that 79, and taking into account the 80s and the 90s there are 7 numbers above that 79. So that's a good double check of picking the median from a stem and leaf plot. Question 10. Find the mean from the stem and leaf plot below. The mean is the sum of the values divided by the number of values. Here, the sum of the values, if we run all those through our calculator, we'd have to do 53 plus 61 plus 67 plus 69 plus 70, etc. Don't forget these are 2-digit numbers here shown in this stem and leaf plot. They would add up to 1155. And the number of values, we'll just count the numbers, the digits in the leaf section. So there are 4, 8, 12, 13, 14, 15, I believe. So just the numbers, the digits in the leaf section will give us the total number of values. And we'll do that division and we'll get a mean of 77 for this set of scores.